This is a graph of sine of x. The derivatives of trigonometric functions are super unique. Let's check this out by sketching. Remember, the derivative represents the slope of the tangent line, or the instantaneous rate of change. When x is 0, the tangent line has a slope of 1. So on our y-axis, let's place a point to keep track of the derivative. At point 0, the function has a derivative of 1. As x increases, the line tangent to sine of x still has a positive slope, but the slope slowly decreases. At pi over 2, the slope flattens out, so there's a derivative of 0. And beyond this point, the derivative turns negative because sine of x starts decreasing. As we continue plotting points based on the slopes, we notice a familiar pattern. What does the graph of the derivative of sine of x look like? That's right, cosine of x. So that means the derivative of sine of x is cosine of x. How cool is that? Okay, now what about the derivative of cosine of x? Let's sketch this out just like we did with sine of x. At 0, the tangent line of cosine of x is flat, so the derivative of cosine of x is 0. As x increases, the derivative of cosine of x decreases until it reaches pi over 2, where it slowly stops decreasing. As we plot points for its derivative, we see that cosine of x follows a pattern we know as well, negative sine of x. So this shows that the derivative of cosine of x is negative sine of x. And how cool is that? The derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. Now, this pattern extends beyond sine and cosine. Let's quickly check out some other derivatives of trigonometric functions. If we sketch tangent of x, we see that near 0, the tangent line is a straight line with a positive slope of 1. As x approaches pi over 2, the function grows steeply toward infinity, so the derivative will increase dramatically. Add more points, and we see that this graph of the derivative is secant squared of x. So the derivative of tangent of x is secant squared of x. And here's secant of x. Since secant of x is defined as 1 over cosine of x, it has vertical asymptotes where cosine of x is 0, such as pi over 2. The derivative of secant of x is secant of x times tangent of x. Similarly, here's cosecant of x, or 1 over sine of x. Its derivative is negative cosecant of x times cotangent of x. And lastly, here's cotangent of x, the reciprocal of tangent of x. The graph of the derivative follows the pattern negative cosecant squared of x. Now, that's a lot of derivatives. Here's a list of all the derivatives that I just mentioned. It's so cool how all of these are related. What's not cool is remembering these. To remember these, look for consistencies and tricks that can help you to remember. One thought that helped me memorize these is the functions that start with c, cosine, cosecant, and cotangent all have negative derivatives. Also notice that both tangent and cotangent have squared derivatives. So just review these regularly and look for memorization tricks like these, and you'll be finding these derivatives in no time. Hopefully this video gave you an intuition of why these derivatives work, and hopefully it also shows you just how cool math really is. All these random functions in middle school actually have meaning, so don't stop learning now. Also, don't forget to leave a like, subscribe to the channel, and share this video with friends. These videos take a lot of time to make, so I really appreciate all of you viewers who take time to watch these. And I'll keep working hard and keep learning. Thank you for watching.